all of us would like our guests to give us a call to tell us that they are coming so that we are prepared for their arrival. And it's pretty much the same with coastal flooding. I am Emiliano Renzi, and I'm working as a researcher at University College Dublin on a new technology for the early detection of coastal flooding. So what is this about? Well, as you can see in the picture, we all know that when we have a very strong storm over the sea, it generates large waves. And these waves can actually kill people, like it happened here in France, in Biarritz, during last winter. What is interesting is that the same storm is able also to create acoustic waves. So these waves here, these are sound waves traveling underwater, and they are very special. They are like Superman. They really travel very, very fast. So my research is about aims to build a new technology for the detection of these acoustic waves with a microphone. It's called a hydrophone, and it's an underwater microphone. So if we'll be able to detect these waves, we'll be able to predict the incoming inundation much in advance. And this will in turn enable us to, of course, save lives and reduce relief and reconstruction costs arising from coastal flooding. Thank you very much.
Thank you.
I will kindly ask you all to close your eyes for a second, please. And bring in mind the smell of coffee in the morning, the smell of the soil after the rain, and the smell of your partner's skin. Now you can open your eyes. It's powerful, isn't it? So my name is Kaya Apazoglu, and I'm working on the connection between odors and emotions. And more particularly, I'm working on how the sense of smell might be altered in times of profound sadness, like depression. I guess there's no need to remind you to tell you what depression is and how our tools today are limited in efficacy. So hopefully the results of this research can lead to a diagnostic tool, quick and simple, in early stages of the onset of a depressive episode. Thank you very much.
So globally, 1 in 4 children is malnourished. Every second, 6 children die because of malnutrition. In urban slums, due to poor, unhealthy condition, 103 million children are at risk of malnutrition. So I'm Sophie Goudet. I'm a researcher at Loughborough University in partnership with Southampton University. And so I'm looking at providing evidence to tackle the risk of malnutrition in urban slums. I'm exploring how successful interventions are, what are the impact of those interventions, and how cost-efficient interventions are in terms of saving life of children. I'm also going to be looking at targeting children and how providing a tool to implementing an organization working in slums to target areas where children are mostly at risk. I'm hoping that this research will lead to policy making at national level and targeting and tackling urban malnutrition in slum is crucial. And I hope this research will contribute towards it. Thank you.
I'm Luciano Rasso. I work at IRSTE Montpellier on a project on protecting the city of Paris against the flood and drought by optimal reservoir management. Now, if you look at the Seine River, it transmits a peaceful sense of, relax. But if you are water management researchers, as I am, you know that the river also poses a terrible threat to the city of Paris because water can mount above the river banks and flood Paris, or completely dry out and leave the city of Paris without water. After 1910, when there was a big flood, 4 reservoirs were built up upstream of the city to regulate the flow and then to reduce both flood and drought. However, presently, these reservoirs are operated using old-fashioned rules. So the research question for me is, can we, thanks to less advanced technology, optimal control, optimal use of information, anticipation, coordination, can we get better results and augment the protection and reduce the risk of flood and drought for the city of Paris? Thanks for the attention.
Hello, everyone. Beside 4 seasons, we get another season very evidently each year. Surprised? Yes, it is flu season. Flu comes back every year, and we cannot do much because we do not have immunity against it. Flu virus is changing continuously. I am Dipanita. I am working on evolution pathway of the flu virus, and my work is to predict the next strain of the flu virus before it even appears. Imagine flu virus as a con man who changes its disguise every now and then, and our immunity system as a police. They're constantly in a chase. Therefore, the flu virus is misleading our immunity system constantly. So if the police knows the thief, it can catch the thief. If the police doesn't know how the thief looks like, it cannot catch the thief. Therefore, my work is to predict the next strain of the influenza virus, that is how many disguises the virus can have, and so that we can design a vaccine and protect people. Thank you.
I just came back from fieldwork in Mali, in West Africa, and wanted to share a couple of snippets with you of what's been going on in this country over the past month. A couple of weeks back, 2 aid workers were killed as their vehicle was blown up outside Timbuktu. A week later, a suicide bomber tried to ram his way into a UN peacekeeping camp, killing 4 soldiers. My name is Ruben, and I'm working on how international interventions are being reconfigured in response to this type of unpredictable threats, highlighting the dilemmas and the trade-offs faced by humanitarians and peacekeepers as it seeks to manage risks. My work highlights how security risks may become self-sustaining in creating a vicious circle between militant action and the response to it. Instead of this, we need new modes of engagement, building on local acceptance, and this is what my work will seek to contribute towards. Thank you.
I would like to ask you, do you like mushrooms? Yes, well, I love it too. But even if you like it or not, probably you know that the mushrooms sometimes look the same, but they are species very, very toxic. Well, in the same way that with the mushrooms, the metals like thallium have different species or ionic forms, and these ionic forms sometimes are more toxic than other ones. Thallium, for example, is present in the environment like thallium-1 or thallium-3. And my name is Natalia Ospina, and my work at the chemistry department of the University in Warsaw, in Poland, is to develop analytical techniques to determine a thallium-3 that could be 1,000 times more toxic than thallium-1. Thanks.
Good morning, my name is Anna Reggio. I'm a postdoc at Sapienza University of Rome, and I work on seismic risk. Think about an elastic band. As long as you deform it, this deformation is not permanent. The elastic band can bounce back pretty immediately to its pre-deformation condition. There exists a word to indicate this coalescence of strength and flexibility. This word is resilience. Seismic resilience, which is the ability of an urban community to recover quickly and efficiently from the impacts of earthquakes, is the main idea behind my research project. In order to achieve this objective, preventing building from collapse is necessary, but unfortunately is not sufficient. What we have to do, what I'm trying to do, is to look inside the buildings to ensure the operational continuity of essential services and businesses, because this is the crucial requirement to avoid downtime, economic losses, and social disruption. In this regard, I'm studying the dynamics of engineering systems and equipments to protect their integrity and functionality under the action of earthquakes. Thank you.
I want to talk to you about sleep. You might think that sleep is a nice and pleasant moment in our days, and I think so too. But let me tell you that sleep can be a nightmare, especially if it's associated with illness. So my name is Fabien Guégan, and I'm working in University of Lisbon, and I want to tackle for my project the health issue of African sleeping sickness by designing new and safer treatments for this disease. Let me tell you that African sleeping sickness is caused by a parasite that is transmitted by the bite of the tsetse fly in Africa. This disease is 100% lethal if you are not treated. But at the same time, the only treatment that is available are extremely toxic and kill more than 10% of the people that are treated, just the administration of the treatment. So this is a major issue. So my goal in this disease is to find a new way to treat this disease by not targeting the brain, this is a very sensitive organ, but more by blocking the transmission between the parasite from the human blood to the tsetse fly. Thank you.
So I'd like to take the moment to ask you if you remember your own teenage years, or maybe you even have a teenager at home and you're living it right now. Do you also remember the risks that you took during this period of time, the exploring that you did? My name is Kiki Zanoli, and I work on the adolescent brain. And my research focuses on how social status or social pressure may influence how adolescents take risks, if it has an influence. And I look at it from a developmental perspective. I look at the brain, which is still developing during this period, and also has a very big influence on how we make decisions during our lifetime. I hope to contribute with my research into looking at these aspects and hope to identify adolescents who are maybe more at risk of taking risky decisions than other adolescents.
I think most of you in the room remember this big thunderstorm that occurred in Paris 2 weeks ago, producing large hail. I'm Bogdan Antonescu. I'm studying at the University of Manchester, trying to understand this type of thunderstorms. What I'm trying to study is where, when, and why this thunderstorm occurred over Europe. By providing an answer to these three simple questions, I will be able to develop a model that can be used by weather forecasters to improve their forecasting. It can be used by the insurance company to estimate the risk of thunderstorms over Europe, and can also be used as a baseline to understand the possible influence of climate change on thunderstorms over Europe. Thank you.